Okay, 2011 AB number 5. We are told that in 2010, landfill has 1,400 tons of solid waste. The increasing function W, so W is increasing. That means that W prime is greater than 0. Make that note to yourself. They estimate that W satisfies that differential equation for the next 20 years. W is measured in tons, and T is measured in years from 2010. So this initial condition, beginning in 2010, landfill contained 1,400 tons. That could be written as W of 0 is 1,400 because T equals 0 represents the year 2010. All right, so use the line tangent to the graph of W at 0 to approximate the amount of solid waste the landfill will have at the end of the first 3 months. So first, the line tangent, I need a point, which will be 0, 1,400, and a slope, which will be my derivative, dw dt, such that, and at this point, notice dw dt is a function of W, so I need to plug in 1,400, and so that would be 1,400 minus 300 is 1,100 divided by 25, which I believe is going to be 44. Is that right? I should have done this before I started. Yeah. So my tangent line is going to be y minus 1,400 is 44, x minus 0. So there's my tangent. Then it says use this tangent to approximate the amount of waste at time t equals 1/4. So then my amount at time t equals 1/4 is going to be approximately 44 times 1/4 minus 0 plus 1,400, which you could stop there. This one's pretty easy to simplify. 1,411 tons, always include units. So there is our answer to A. Part B says find the second derivative in terms of W. And so this is going to be an implicit thing. So dw dt is going to be 1/25. I'm going to ignore that 1/25 in front. The derivative of W minus 300 would be 1. But it is implicit. So the derivative of W is actually dw dt, not just 1. And as I was doing that, I caught a mistake in my writing over here. This is not dw dt. This is the second derivative. I need to fix that. So d squared W over dt squared is equal to that. But then they say this needs to be in terms of W. This is not in terms of W. So I now need to replace the dw dt, 1/25, the dw dt with the differential equation. So that'd be 1/25 times 1/25 of W minus 300. There we go. And let's see. Now there's the answer to the first part. Okay, determine whether our estimate in part A is under or over the actual amount of waste. Okay, so what we did in part A is we found a tangent and we plugged a value into the tangent. So this is going to depend on whether this curve is concave up, move that up here, or concave down. So if my curve is concave up, then my tangent is below the curve, and plugging in values to the tangent will give you underestimates. If my function is concave down, then the tangent will lie above the curve, and that tangent approximation would be above the actual function values. So we have to determine, is this function concave up or concave down? And the only thing that's going to matter is this W minus 300. The 1/25s are obviously positive. So what I've got to do is think about this. W minus 300, my initial value, I started with 1,400, and then they tell you that W increases. That's going to be greater than 0 because W of t is always greater than 1,400. Therefore, my second derivative will always be positive, making W of t concave up. Therefore, again, the estimate in part A is an underestimate. Function's concave up. The tangent approximation will be below the actual curve. And let's knock out C really quick, solving a separable differential equation with the initial condition there. And so first thing we'll do is separate the variables. So dw dt. Whoops, I forgot to separate. It's dw. I'm going to divide by the w minus 300. I'm going to leave the 1 over 25 on the right side. So separated, do the antiderivatives. Both sides are pretty easy. For the left side, the top is the derivative of the bottom. So that's going to be the natural log of w minus 300. The right side is 1 over 25t plus some constant. And I'm trying to decide when I want to solve for the constant. I think I'm going to solve for w first. So w minus, why'd that go away? Ah, that's annoying. Now I have that stupid watermark. Whatever. So w minus 300, there we go, would be e to the 1/25th t plus c. I like to bring that c down, make it e to the 1 over 25t. Move the 300 over. W equals 300 plus ae to the 1 over 25t. And I kicked it into autopilot a little bit too soon there, because now when I solve for my initial condition, w of 0 equals 1400. I'll plug 1400 in for my w. I have 300 plus a e to the 0. And the reason I say I kicked in autopilot a little bit too fast is because to solve for a, I now have to move that 300 back over. So I probably should have solved for a right here instead of where I'm doing it now, but it's not that big of a deal. A is going to be 1100. And now I have a full equation for w. 300 plus 1100 e to the 1 over 25t. And that is it for 2011 number 5. Is it number 5? I don't know. Yep, number 5.